Good afternoon, everyone. I hope that everybody's doing great. Happy Friday. We're looking today at lesson 30.12, which deals with the laws of logarithms. And this lesson can be found on page 11 of your current lesson handout. As we move forward here, it's very important that you have a really good grasp of the previous lesson. So if you are still struggling with the meaning of a logarithm or some of the questions from the previous lesson, it's important that you get that cleared up before you worry about this lesson. All right, in grade 9 and 10, you talk a lot about exponent laws, and there's certain rules, which we call laws in mathematics, that you have to follow when it comes to dealing with exponential expressions. Well, since exponential expressions are just a different way to write logarithmic expressions, there are laws of logarithms as well. There's what we call the product law for logarithms, the quotient law for logarithms, and the power law. All of these laws are going to be used moving forward basically to solve equations. Now, you already know how to solve exponential equations if the bases can be written using the same value. But to solve exponential equations where a common base is not possible, you're going to have to use logarithms. And more specifically, you're going to have to use the laws of logarithms to solve those equations. And then when we talk about logarithmic equations in a few days, you're going to need to know the laws of logarithms to work with those as well. So here are the three laws. The first law is the product law. And what it says is that the logarithm of a product is equal to the sum of the logarithms. We can read this mathematically as log base b of m multiplied by n equals log base b of m plus log base b of n. But I think the words are just as important as the equation. The logarithm of a product is equal to the sum of the individual logarithms. Make a note to yourself that when you add two things together, the order doesn't matter. So when we talk about taking log base b of m and adding log base b of n, it doesn't matter the order in which you add them. Now, what does the quotient law says? The quotient law says in words that the logarithm of a quotient is equal to the logarithm of the numerator minus the logarithm of the denominator. Log base b of m over n is equal to log base b of m minus log base b of n. But you should know that when you subtract things, the order in which you subtract them becomes important. So in the product law, the first law, you can add those two logarithms in any way you want. But in the quotient law, you must take the logarithm of the numerator and subtract the logarithm of the denominator. And the power law, which is going to be the most useful one for solving exponential equations later, is that a logarithm of a power is equal to the exponent times the logarithm of the base. Now, those of you in calculus, do not confuse this with differentiation when you move an exponent out in front. It looks similar, but we're not differentiating here. So this says log base b of m raised to the n is the same as n multiplied by log base b of m. And I want to talk about these three now using a specific example. So before I use an example here on the calculator, I want to review something with you from the previous lesson. When you see something like log of 100 and the base is not written, this is log base 10. When the base is not written, it's understood that we are talking about base 10. And if I were to ask you what log base 10 of 100 is equal to, from the last lesson, it's equal to the exponent to which you raise 10 to get 100. This is the most useful way to think of a logarithm. A logarithm is the exponent to which you raise the base to get the argument, which in this case is 100. That means log base 10 of 100 is 2. 10 squared gives you 100. And I didn't point this out to you in the last lesson, but when you take a look at your calculator, you actually have a button that has the word log on it. It's on the left-hand column of buttons, right to the left of the number 7 on the keypad. So if I want to find the log of 100, I can just enter log of 100. And it tells me the answer is 2. So we have one particular logarithmic function on our calculator that we can use. Now let's talk about the product law. If I wanted to show you that this works, I could say, what is log base 10 of 3 multiplied by pi? What does that equal to? And you could use your calculator. If I said to you, what is log base 10 of 3 plus log base 10 of pi, you could use your calculator. What the product law is telling you is you are going to get the same answer. So if I take the logarithm of 3 multiplied by pi, this is a base 10 logarithm, I get 0.9742711,274. On the other hand, if I take log base 10 of 3 and I close the brackets and add another logarithm, which is log base 10 of pi, I get the exact same answer. So that's what this product law says. The logarithm of the product and the sum of the logarithms are equal. That's what the product law says for logarithms. What the quotient law says is the logarithm of a quotient is equal to the difference of the logarithm. So I can pick some numbers again. I'm going to go again with log base 10, and the reason I'm doing that is I can use my calculator to show you that this is true. Of 17 divided by 3. So that means on the other side, I'm going to evaluate the log base 10 of 17 minus the log base 10 of 3. Again, with the quotient law, it's important that you take the logarithm of the numerator, which is on the top of the argument, 17 in this case, and subtract the logarithm of the denominator, which is on the bottom of the argument. If I calculate log of 17 minus log of 3, I get 0.7533 something. If I take the logarithm of 17 divided by 3, and that means it's going to divide 17 by 3 and then take the logarithm, I get the same answer. So that's the meaning of the quotient law. And all of these laws, I'm demonstrating the truth of them to you by using a common log, but it doesn't have to be a common log. If we had a way to calculate log base 3s and log base 7s and log base 0.5s, we would find the same thing would happen. The most important law in terms of logarithms is called the power law. What this says, as an example, is that if I wanted to determine the log base 10 of 7 to the 11, I could instead take 11 multiplied by log base 10 of 7. So log base 10 of 7 raised to the 11 gives me 9.296. 11 multiplied by log base 10 of 7 gives me 9.296. They're equal to each other. And that's the meaning of the power law. All right, let's take a look at some examples. The first example asks us to write each expression in terms of individual logarithms of the variables. I want to point out to you that when you see log base 3 and then it's followed by x squared y, it's implied that it's the logarithm of the entire thing. Well, since it's a logarithm of a product, the product law says I can take the sum of the individual logarithms of the things that were being multiplied. Logarithm of a product is equal to the sum of the logarithms. And finally, what I can do is I can write this first logarithm as 2 log base 3 of x, and then I have plus log base 3 of y. I want to point out something that I talked a little bit about in the last lesson. You want to write things in a very tidy way. For example, the y, the log, the x, and the log are all written on the same line. Whereas the squared, the 2, is written as a superscript, and the 3's are written as subscripts. Everything is lined up nicely. Anyway, the correct answer is 2 log base 3 of x plus log base 3 of y. All right, example B, log base 6 of x divided by z cubed, while the logarithm of a quotient is equal to the logarithm of the numerator minus the logarithm of the denominator. And then we can take that exponent that's on the base of z and move it out in front. We're using then the power law to write the second part as 3 log base 6 of z. And that's the answer to B. Look at C. We need to go back into the depths of Math 10C and Math 9 here to remind ourselves that when you have an nth root of something, that's equal to that thing raised to 1 over n. And what that means is that this is log base 7 of x to the third over y to the half. And we can certainly split that up using the quotient rule. The logarithm of a quotient is the logarithm of the numerator minus the logarithm of the denominator. And now we can swing those exponents down in front and have 1/3 log base 7 of x minus 1/2 log base 7 of y. And that is our answer in this question. Incidentally, I have no problem at all with anybody going from this point down to this point in one fell swoop. I think visually a lot of people see as soon as they're about to write this, people visually see what's going to happen almost at the instant their pencil starts touching the paper. That third is going to go in front. So you certainly don't need to write that middle line. And D, what is log base B of x to the 4 over y to the 10 z to the 3? So I'm going to do this one in stages and then show you a shortcut for this, because there's a very common mistake that students make mathematically here. Since it is log base B of x to the 4 over y to the 10 z cubed, we can use the quotient law and write log base B of x to the 4 minus log base B of y to the 10 z to the 3. This is log base B of x to the 4, and I know that you can move the 4 in front, but I'm just going to save that. Minus, what this is a logarithm of a product. The product is y to the 10 multiplied by z cubed, which means that this becomes log base B of y to the 10 plus, because it's a product, plus log base B of z cubed. Now, if you write that, you've made a mistake. And this is a mistake that I've pointed out to you probably 10 times in the first 5 to 6 weeks of classes when we were in the building together. The mistake here that is going to lead you down the wrong road is that you have to subtract the whole thing. When you're subtracting a sum, you have to subtract the entire sum. Now what happens here, and I'm leading up to the shortcut, is we can take the -1 in front and multiply it by each of these logarithms and end up with the following statement. We have log base b of x raised to the 4 minus log base b of y to the 10 minus log base b of z cubed. And in the top corner here, I'm going to write down what the original expression was. It was log base b of x to the 4 over y to the 10 z cubed. And here is the shortcut. The shortcut is that anytime you have a piece of the argument, I'll remind you what the word argument means in mathematics. The argument is the thing that you're operating on. So the argument of a logarithm is the thing that you are logging. That's not a proper mathematical term, but I hope you catch my drift. The rule is this: if you have a piece of the argument that's on the top, then that individual logarithm, when you split everything out, becomes positive. When you have a piece of the logarithm that is on the bottom, when you split it out into separate logarithms, that logarithm becomes negative. So since x to the 4 was on the top, the coefficient of the individual logarithm with x to the 4 is positive. Since y to the 10 was on the bottom, the coefficient of that individual logarithm is negative. And since z cubed was on the bottom, that has a negative coefficient as well. Top is positive, bottom is negative. We can finish this problem off now. And by the way, I should point out, the usefulness of that rule is you don't have to do this. You can bypass that whole step and pretty much go from the original question to this line. Our final step, of course, is to move those exponents in front, giving us 4 log base b of x minus 10 log base b of y minus 3 log base b of z. And you know, the reason why we're doing this, there's a whole bunch of reasons why you're learning this. One is to develop better mathematical skills, so when you move forward to either calculus or post-secondary, you're better prepared. The other reason is we're going to be learning how to solve certain equations that require us to do this. So it's a prerequisite skill in moving on, and it's also a skill that will just develop better mathematical muscles in your brain. All right, number 2 asks us to use the law of logarithms to simplify and evaluate each expression. Now, I want to point something out to you. If I said to you, what is log base 2 of 40? And what is log base 2 of 5? Now, the problem here is you can't figure out what log base 2 of 40 is. Log base 2 of 40 is the exponent to which you raise 2 to get 40. And since 40 is not a power of 2, you can't figure it out. And the same goes with log base 2 of 5. But if we pack these two separate logarithms together by dividing the arguments, so we are doing the opposite of what we did in the last question. In the last question, we had a logarithm of a quotient and we split it up into a difference of logarithms. This time we're taking the difference and packing it together in a single logarithm. Well, 40 divided by 5 is 8. So this is log base 2 of 8, but log base 2 of 8 is the exponent to which you raise 2 to get 8. and that is 3. So log base 2 of 40 minus log base 2 of 5 is equal to 3. What about log base 3 of 45 plus log base 3 of 15 minus log base 3 of 25? 45, 15, and 25 are all numbers that are not powers of 3. So you can't figure out the exponent to which you raise 3 to get 45, or the exponent to which you raise 3 to get 15, or the exponent to which you raise 3 to get 25. But if we put these together as a single logarithm, we would have 45 multiplied by 15 divided by 25. Remember, if the logarithm is positive, the argument goes on the top. If the logarithm is negative, it goes on the bottom. Well, now we can figure out what this argument is by taking 45 multiplied by 15 and then dividing by 25. I want to say that we're going to get 27. And log base 3 of 27 is the exponent to which you raise 3 to get 27. Well, 3 cubed is 27. Next question. We're going to move the coefficients that are out in front of the logarithms up as exponents. So we are doing the opposite of the power rule. Now we can put these together and write a single logarithm of the product of 5 squared and 20 squared. Don't forget this is log base 10. That means this is log base 10 of, well, whatever 5 squared multiplied by 20 squared is. 5 squared is 25 multiplied by 20 squared gives me 10,000. So this is saying, to what do I raise 10 to get 10,000? Well, 10 times 10 times 10 times 10 would give you 10,000, so you raise 10 to the 4. Log of x cubed minus 3 log of x. There's a number of things I can do here. One of them is I could take the 3 that's an exponent in the first logarithm and move it out in front and have 3 log x minus 3 log x. Well, that will be 0. The other thing you could have done is left the log of x cubed alone, and in the second logarithm moved the 3 up front, and you have log of x cubed, which is 0. I guess what we could have done as well is done the following, said that since it's a difference of logarithms, I can take a single logarithm of a quotient. X cubed divided by x cubed is 1, so we have log of 1. And log of 1 is saying, to what do I raise 10 to get 1? And the answer is 0. A power of 0 always gives you 1. Number 3, what we're doing here is the exact opposite of what we did in question 1. We are packing things together. And I am going to use the shortcut rule because it makes our lives so much easier. We're going to pack this together as a single logarithm, and any logarithm that was positive is going to have an argument that goes on the top of the single logarithm, and any logarithm that was negative is going to have an argument that goes on the bottom. And that's the answer. That's all you have to do. Same thing here. We can put all of these together as a single logarithm. It is base 2. Any logarithm that was positive, which are the first two, will have their arguments land on the top. and any logarithm that is negative, which the last two are, will have their arguments land on the bottom. And then we can simplify that expression. The new argument, I have 2x squared over x squared y. All of the x's cancel, and I'm left with 2 over y. And that's the answer. Or I could write log base 2 of 2 minus log base 2 of y. And log base 2 of 2 is the exponent to which you raise 2 to get 2. So we could have this as an answer. See, the only reason I'm adding an additional example here is before you pack logarithms together, you have to make sure that the coefficients have been applied using the power rule so that they are an exponent. In other words, we have to write this as log of x cubed minus log of y to the half. Now we can pack them together. It's a difference, which means the single logarithm will be a quotient. The logarithm that was positive has an argument that goes on the top. The logarithm that's negative has an argument that goes on the bottom. And I would be inclined to write root y rather than y to the half. There's your assignment on page 400, numbers 1 to 3. This is the same kind of idea I'm going to tell you right now that I told you with trigonometric identities. When we learned about trigonometric identities, it was very new to all of you. And I said that your goal was every day you work on these, you understand it better than the previous day. You're more successful every time you do some of the problems. And that's what I would tell you here. When you start off with some of these, the first questions you do on your own, you might struggle a bit with. But the more and more you do, the less and less you'll struggle. And after a while, it will just become very simple. It's hard to believe because some people struggle with logarithms. And if you're one of those people, it's hard to believe that this is going to become simple. But it will with practice. I hope that you have a wonderful rest of the day and you have a fantastic weekend, and we will talk to you soon. Take care.